If you want to add authentication to your application or secure your APIs and do all of that with minimum effort, then Keycloak is the solution for your problems. In this video, I'll show you how you can get started with Keycloak, how you can run it locally in a Docker container, and how you can use it to obtain an access token using the industry standard Authorization Code flow. Keycloak is an identity and access management platform, what you would typically call an identity provider. It's open source and free to use, and it's easy to run it as a Docker container. There's a useful guide on their website how you can get started with running Keycloak, and I'm going to copy this command here. This is going to start a container running Keycloak using the latest version. Now, to make this repeatable, I'm going to add a Docker compose file in my folder, and let me copy this command. Now, to be able to better see what we have going on here, let me add a couple of more lines, and I'm going to extract the individual arguments here. So we have a Docker run exposing Keycloak on a local port. This is the image that we're going to run. So we're running Keycloak version 26.5.0, and we have an additional command here called start dev to run Keycloak in development mode. So then I'm going to say services, and we want to define our first service. And you can see I'm getting a code completion here. So we're going to define the Keycloak service. We want to run the image that we have above, version 26.5.0. We are also setting some environment variables, which represents the admin username and password. You're going to use this to access the Keycloak management console. We are running it in development mode, which is going to use an embedded database, and we're making it available on the local port of 8080. So then to run this, I'm going to need a new terminal, and I'm going to say docker compose app. This is going to build my docker compose file, fetch any images that might be missing, and it's going to start Keycloak. If I open up Docker desktop, you can see that we have the Keycloak container running locally. And if you're running it for the first time, it might take a couple of moments for Keycloak to become responsive and start accepting your requests. But when you access Keycloak at this address, and you should see a user interface that looks something like this. Here we can input our admin username and password and sign in, and this should unlock access to the Keycloak management console. From here, I'm going to click Manage Realms, and I want to create a new realm for this demo. And for lack of a better name, I'm going to call this realm the demo realm. So we are now in this realm, and you can think of a realm as a logical grouping of clients representing applications and any users that might be a part of it. A nice way I like to think of it is it's like a schema inside of a database. Now, the clients represent applications or services that can request authentication on behalf of a user. So Keycloak implements the popular OAuth 2 standard, which we use to be able to reliably authenticate a user to obtain an access token, and then we use that access token to access any protected information on a resource server. Keycloak also implements OpenID Connect, which is an identity layer on top of OAuth. Now you can see our realm comes with a bunch of default clients, which we won't be needing. Instead, we want to create a new one. And for the client type, I'm going to choose OpenID Connect. Then we have to give our client a unique ID. I'm just going to call this the public client because I want to use it from some sort of client-facing application where I can securely store a client secret. An example of this might be a single page application or a desktop application, and a secure application might be a web app running on some server in the cloud where you can securely store a client secret. From here, I'm going to click Next, and from this screen, we get to choose if this is going to be a public client or a confidential client. If we leave it off, it's going to be a public client. And from the authentication flows, we are most interested in the standard flow, which uses an authorization code. You could also use a direct access grant, where you can directly exchange a username and password for the access token, although this is not recommended, and you would typically want to do this with a confidential client. So I'm going to leave just the default settings here, and for the PKCE method, or PKCE, which is short for Approved Key for Code Exchange, we want to choose which hashing algorithm we want to use when hashing the code verifier. I'm going to explain what this is in just a moment, but I'm going to choose SHA-256 and I'm going to click Next. And here we just want to set the valid redirect URIs, and I'm going to add this value, which is a callback endpoint for Postman that is going to allow us to use the authorization code flow from our local Postman instance. So with this, I'm going to click Save, and we have our public client. Now, the second thing we need is a user to be able to authenticate with. So let's create a new user here, and I'm just going to create a dummy user. Let's say test@test.com. Let's use the same for the email, and then the first name are going to be test and test. Now I'm going to say that the email is verified and create this user, and we want to give them a set of credentials. I'll just say 123123 and turn off temporary because I actually want to use these credentials. So now we also have a dummy user. The next thing we need is to understand the authorization code flow. Here's a diagram explaining how the authorization code flow with PKCE works in practice. I got this image from Auth0, which is why you see Auth0 here. But in our example, this here is going to be Keycloak. So how does the authorization code flow with PKCE work in practice? We have a user inside our application that wants to log in, and they click some login link in the application, which does two things. It generates a code verifier, which is some cryptographically safe random string, and it hashes it to produce a code challenge. This is the PKCE part of the authorization code flow. It then sends an authorization code request with the code challenge that we generated in the previous step to our authorization server, which is Keycloak. And there's a set of standard endpoints that you can call for this. And the one for obtaining an authorization code is the authorize endpoint. What happens next is we redirect the user to the login screen of our authorization server, in this case Keycloak, where the user enters their credentials, and then Keycloak is going to validate these credentials, and if it confirms that they are successful, it's going to redirect the user back to our application, but it's also going to return an authorization code. We then send this authorization code together with the code verifier that we generated at the start of this entire flow back to our authorization server, Keycloak. And what happens is Keycloak stored the code challenge from our previous step, and when we try to exchange an authorization code for an access token, it's going to validate if the authorization code is valid, and it's also going to check the code challenge that is stored previously and compare it to the code verifier, which gets hashed, and if these values are the same, then it's going to return an ID token and an access token together also with a refresh token and return those to our application. Finally, our application is able to request user data from our resource server, which is typically your API, using the access token that we obtain. So you can see all of this is pretty complicated, and rightly so, because the purpose of this is to harden the security of your application, prevent many type of attack vectors, for example, if the authorization code is compromised, because an attacker won't be able to exchange it for an access token without the code verifier that we generated at the start. Now, hopefully you understand how the authorization code flow with PKCE works and how do we actually use this in practice. I'll switch to my Postman instance, and if you try to send a new request, you'll see an authorization tab here where you can choose OAuth 2.0 for the authentication type. Now we are obtaining the bearer token, so I'm going to leave the header prefix as the default value, and what we want to choose is the grant type. This basically represents which flow you want to use to obtain an access token. In our case, authorization code with proof key for code exchange. Then you can set the callback URL, or you can use the default one from Postman, which we configured earlier in our Keycloak client, if you remember. You can also set this value manually. Then we have to provide the authorization URL, which is used to get the authorization code, and the access token URL. So how do we get these values? Most of these things are standardized, and we can send a request to our Keycloak instance, which, if you recall, is running on port 8080. Now we have to scope our request to the current realm, which is called demo, and the endpoint I want to call is well-known/OpenID-configuration. If we send this request, we should get back a successful response, which contains some publicly available information for your Keycloak realm. Now, out of all of these, what we are interested in is the authorization endpoint that we can set here, and this is where we get our authorization code, and also the token endpoint that we can use to obtain an access token. So let's set both of these values. Then our client ID is just public. This is what we named our client. And then we configure the code challenge method as SHA-256. Here's the field for adding a code verifier. I'm going to let Postman generate this, and you want to scroll all the way down and click Get New Access Token. So this is going to redirect you to our Keycloak instance, where you can authenticate on behalf of a user. So if I add the user's credentials and click sign in, Keycloak is going to verify this information and then return an authorization code back to Postman, which is then going to request an access token, which you can see here. So we get an access token and a refresh token back in the response. You can also see the grant type here as authorization code with proof key for code exchange. So if we grab this access token and we head over to jwt.io, we can drop in the value that I just copied from Postman and take a look at what we have inside of the access token. So you can see which algorithm was used to sign this value, the contents of the header, the payload, and the signature. And inside of the payload, we can see who is the issuer, our demo realm, which we created at the start of the video. We can see a unique ID for the currently authenticated user in the subject claim, and then a bunch of additional claims for this user that we can use for authorization purposes, for example. If you're wondering how our application is able to verify that this is a valid access token, it does so by validating the signature, which you can actually do here by adding the public key. If I go back to Postman for a moment, and our OpenID configuration, there's a value here that contains the public keys for our Keycloak realm. If I call this endpoint, I can get the public keys back. Here's the public key for the RSA algorithm, but we are actually using the RSA 256. So this is the public key value. And if I add this in jwt.io, but I have to prefix it with begin certificate and end certificate, and then paste it in this format, you can see that we are able to validate the signature of our access token. So this is essentially what our API does to validate the access token. It reaches out to Keycloak, gets back the public key, and then uses it to verify the signature that is part of the access token. Finally, because we lack a backend API to test this against, I'm going to call this endpoint on our realm. It's protocol/OpenID Connect/user info, and this should allow me to get the user information for the currently authenticated user. Now you can see that I'm getting back a 401 unauthorized response. This is probably because I didn't choose which token to use, so let's choose the one we got earlier. And now the response changes to 403 forbidden, which means we know who you are, but you don't have access to this resource. And the reason for this is because this is an OpenID Connect endpoint, and I didn't request the OpenID scope when I retrieved the access token. So if we add OpenID in the scope field, and we send another request to get the access token, and we use this token, and I resend the same request, you can see that we now get back the 200 OK response, which contains the information for the currently authenticated user. And this is how we could obtain the current user's info from our Keycloak instance. If you don't want to go through this process manually to get a new access token inside, you should leave this option on, where Postman is going to automatically refresh your access token, and you can seamlessly continue sending authenticated requests to your API. So this covers how to get started with Keycloak locally and use the authorization code flow. If you want to see how you can integrate Keycloak with your backend API running in .NET, then go ahead and check out this video next. Make sure to smash the like button if you enjoyed this video. Thanks a lot for watching, and until next time, stay awesome.